Yeah, good afternoon. We'll start with the lesson. In the last class, we are discussing on the Ethernet protocol, how an Ethernet adapter and how an Mac protocol, media access control protocol, will works on CSMA collision detection system. We had seen that particular thing in a last class. Coming to the next session. In a last class, we have seen how the frame format of an Ethernet will be there. Preamble will be of a 64-bit will be there, and a 48-bit hexadecimal address will be there of 48 bits. That is the bits of the information will be there. So six bytes will be taken into the consideration, and that each one byte will have a two hexadecimal numbers there. So it will be represented like that. That two hexadecimal numbers will be converted to the binary numbers. That is the for your source address will be there, MAC address, and destination MAC address will be there. And afterwards, the type of a packet, 32-bit will be there, and 1500 bytes, the body, the data will be there. Then afterwards, 32-bit, the CRC will be there. So this we had discussed in our last class, the frame format of the Ethernet. And after discussing the frame format of an Ethernet, we have gone with other things. Now I'll share this slide. Sorry, share this slide. Now we'll start with our lesson further. Yeah, in the last class that we have discussed the frames addressed to its own addresses, that also we have discussed in the last class. So coming over here, we have seen how the address will be there, and each adapter will have its own permanent physical address we'll call, and IP address will be the logical address that I told you that will be there in a network layer. But in a MAC layer, that is data link layer, whatever is it, that will be in a MAC address will be there, which is a permanent physical address which will be there on each adapter. That will be of 6 bytes, and 1 byte means 6 parts will be there separated by 6 bytes is separated by a colon, and each byte represents two numbers of hexadecimal. Coming to the next thing, how the first 3 bytes will be reserved for a companies like our mobile numbers, as I told in a last class, where the uniqueness of the IP address means MAC address will be maintained. And in a last class, we have discussed that for a unicast, the MAC address will be used. That is single source and a single destination. If it is broadcasting, all ones will be there. And if it is the multicast means many sources and many destinations is there, so then the first bit will be 1. That also we had discussed in a last class. So these things which we have discussed in the last class, now we will step into the today's lesson, that is Ethernet transmitter algorithm. Now how a transmission of an frame will be done in a Ethernet adapter, that we are going to see, and how algorithm way is going to be worked in a adapter. So when the adapter has a frame to send and the line is idle, it transmits the frame immediately. First, what the adapter will do, the frame is there with an adapter to send. First, it will check whether the line, the channel is idle or not. If channel is idle, none other than using that, then automatically it transmits the frame. The upper bound of 1500 bytes in a message means that the adapter can occupy the line for a fixed length of a time. That is 1500 bytes of an entire thing should be sent. The line will be synchronized by means fixed by the particular time by that particular sender. Then when the adapter has a frame to send and the line is busy, assume in the next case, assume the adapter has to send a frame and the line is busy. It waits for a line to go idle. Means it will wait until the line gets idle, and then it will transmit the frame immediately. And this Ethernet algorithm, we'll call it as one persistent algorithm or one persistent protocol. That is the probability of the sending of an transmitting of an frame will be 1 whenever a busy line goes idle. That means whenever the busy line goes idle, then the frame will be transmitted. Otherwise, the frame will not be transmitted. Then this algorithm is called as a one persistent algorithm. Next, coming to the things. Now, in this particular case, okay, if single system is connected to a channel or a line, then it's okay that it will check for an idle or an busy. Assume that other systems also connected. Okay, then assume the situation like this. At the same time, two devices or two systems will check whether the line is idle or not. At the same time, the line is idle. At the same time, if the line is idle, both systems will send a frames, correct? Then automatically a collision will be there. Then what it will do? So that we'll see in the next coming slide. Now, since there is no centralized control, means there will be no centralized control, the individual systems or devices is sharing the one particular line. It is possible or for two or more adapters, maybe two or more adapters to being transmitted at the same time. Same time, the frames can be transmitted. Either because both found the line to be idle. That means the devices, whatever is connected, assume line is idle. Both at the same time, they'll say, yes, line is idle, they will send a frames. So they are both being waiting for a busy line to become idle. Assume line is busy. At the same time, both are waiting to the line becomes idle. Then both will send an frames. Then also there is a chances of a collision. When this happens, the two or more frames are said to be collide on the network. Means the two frames will collide on that particular link. So for this, the collision detection must be there. Now you see, since Ethernet supports collision detection, Ethernet CSMA/CA, that is collision detection, sorry, /CD, that is collision detection algorithm will also be there. Each sender is able to determine that a collision is in process. That is, once the frames has been sent at the same time, the senders who have sent that particular frames, they must determine that yes, collision is occurring at that particular sense. How it will listen the collision? As I told you in our last class, whether it is receiver side or on a sender side, either the systems will listen and they will detect the collision. At the moment an adapter detects that its frame is colliding with another, it first makes sure to transmit a 32-bit jamming sequence and then stops transmission. What do you mean by this? Now it's very simple. Now once the collision has been detected, means listened by that particular sender system, or sender system comes to know that there is a collision occurring, what it will do, it will send 32 jamming bit sequence or bit jamming sequence. That is a dummy bits it will send. Again, if collision is occurs, then it will things like that, yeah, busy, it is busy, the line is busy, so it will wait for another time, means another sequence of a time or another quantum of a time. Then it stops transmission of its frames until the line becomes free. Then afterwards it will transmit the frame. Now you see in the next slide, once an adapter has detected a collision and stopped its transmission, it waits a certain amount of time and tries again. So once a collision has been detected and 32 jamming bits has been sent in a sequence, then it will wait whether another collision will occur or not. It will wait for some particular time. After waiting for particular time, nothing has happened. Now the link is idle. Then automatically the retransmits of the frame will be done. The waiting of a time will be there. Know how much time it will wait. Each time the adapter tries to transmit but fails. It doubles the amount of the time it waits before trying again. Now assume, this is very important thing, that is, first time the frame collision has occurred, the jamming bits has been sent and it's waiting. Next second time, it thinks that the link is idle, again it will send a frame. Assume now also a collision occurs, then it will doubles the time. Waiting time is doubles, means the amount of the time will be doubled. It will wait another double of the previous time. Again, if it feels that yes, link is idle, again it will send. Assume third time also frame collision occurs, then the whatever the three times means doubles. It will doubles another time, it will wait. for again the amount of that time, then again it will retransmit. So this will be there in exponential nature. That is the doubling means, for example, I will tell you 1 minute it will wait. Again, after waiting a 1 minute, it will send, assume it will become a second minute, it will send a frame. Again, collision occurs. Then again, it will wait for another 2 minutes. Again, 2 will become 4 minutes. 4 will become 8 minutes. 8 will become 16 minutes. 16 minutes will become 32 minutes. Like that. Just I'm telling in a minutes, but it will works in a microseconds. So just for understanding of you, I'm telling like that. Like this, the doublings of things will be there. And this strategy of interval means waiting time for a retransmission of a frame, we'll call it as an exponential back off. In short notes, they will ask you, explain exponential back off. Exponential back off means in a collision detection system, once the collision of the frame has been occurred, the sender will send a 32-bit jamming sequence and it will wait for certain time. So after waiting, again the link is idle, it will send a frame. If second time also collision occurs, it will doubles the waiting time. Like this, it will keep on doubles the waiting time until the no collision will occur. This sequence is, we'll call it as an exponential backup. So that underline that particular word, what is exponential backup. Coming to the next slide. Now, the adapter first delays either 0 means 0 microseconds or 5.12 microseconds selected at a random. So first time assume collision occurs, then 51.2 microseconds it will wait. Microseconds, keep in your mind, microseconds. Then if this effort fails, second time also fails, it then waits 51.2 double of that, 102.4 microseconds. Then again files doubles of that, that is 153.6 microseconds selected randomly before trying again. Now this is how this formula will work. K into 51 into 2 formula has been used, where K is sequence of numbers starting from 0, 1, 2, 3. Right. So how the K is defined? K is defined on a number of collisions occurred. How? Assume that the collision occurred is N. That is after the third collision. So the K will be taken. How K will be taken? K will be taken from 0 to 2 to the power of 3 minus 1, where 3 is the third collision. That is N number of collisions. That is 2 to the power of 3 means 2 to the 4, 4 to the 4 to the 8. So 8 minus 1, that is 7. So 0 to 7, it will take of that particular K. And then it will 0 to 7, it will keep on into 51.2. That particular time, it will wait. Next, so how in general, the algorithm randomly selects a K between 0 and 2 to the power of N minus 1, where N stands for number of collisions. And the K, the waiting time is always defined by K into 51.2 microseconds. This is the formula. The waiting time will be always defined K into 51.2 microseconds. How K is defined? K is defined from 0 to 2 to the power of N minus 1. How N is defined? N is the number of collisions occurred till now. So that in this way, the Ethernet transmitter algorithm will work in case of an collisions. Now, experience with an Ethernet. Ethernets work best under lightly loaded conditions. What do you mean by that? Lightly loaded conditions means where less number of devices. Under heavy loads, too much of the network's capacity is wasted by collision. So if you have a more systems, then automatically collisions will become more and retransmission will become more. There, the network capacity will comes down. Most Ethernets are used in a conservative way. How have favor than 200 hosts connected to them, which is far favor than the maximum of 1024. Maximum almost all 200 hosts will be connected, where maximum is 1024. So if 200 hosts are there, it will works best. That's why every 200 systems, one LAN will be made usually in a real time. They were in a LAN network where Ethernet network, they don't take more than a 200. If more than 200 systems is there, they will make two networks. So like that they are going to do. Most Ethernets are far shorter than 2500 meters with a round trip delay of closer to 5 milliseconds than 51.2 milliseconds. So maximum in a LAN, it will be of 2500 meters they are telling, but in real time if you take around the LAN, it never crosses, according to me, the 500 to 800 meters in real times, where LAN will work very good. So that is like one big hall. If you take that all, you can have one particular LAN like our lab. So whatever 30 systems you are going to connect, two labs if you take into the consideration, maximum 60 systems like that. So 200 systems, so one big hall will be there. If you consider that how many meters is there, around maximum around 1000 meters. In reality, it will works good and it's closer to the 5 milliseconds rather than a 51.2 milliseconds where Ethernet works still good. Ethernets are easy to administer and maintain, because why, after 20 years of this investigation of this Ethernet, still Ethernet is there, and it has become a backbone of network or an internet. Why? Because the administrating of a Ethernet is very easy and maintenance is. There are no switches that can file, and no routing and configuring tables that have to be kept up to date. You know that risks, nothing will be there. So it will works, means one hub will be there in our lab, like all systems is taken there and it has been connected to that particular hub. Now the hub will become one particular line. That's a busy line. That's it. Maybe collisions will occur in that particular place. This is a real-time example that I am going to tell you. I will tell once again. In our lab, MCA lab 1 and lab 2 is there. In a lab at a corner, you can see the switches. Whatever a switch is there, that we'll call it as a switch hub. So what actually we will do, we'll take all the Cat6 cables of individual systems and we are taken connected to that particular switch or a switch hub of 24 ports or 32 ports. It will be like that, and 48 ports. In our lab, we are having 232 port hubs, switch hubs. So we'll fix there, and all that has been connected to that. That means all systems is connected to that hub. That hub will become one busy line. In the lab programs, when you are doing using in a part B, when you are doing using a network simulator, there one LAN program is there. There you can see how different systems is connected to one particular switch or a hub line. So there you can see, and how that hub line or a switch line has been shared by all other systems that you are going to see in that particular lab program. Now, it is easy to add a new host to the network. It's always easy. For example, I'll tell you like this. In our lab, we are having a 32-bit port, means 32 port switch hub 2 we are having. That means 32 plus 32, almost 64. 64 systems you can add up. Now we are having only around 30 systems. So 30 means another means 34 systems you can add up in our lab. It depends like that. Just if you increase the switch hubs, then automatically it will keep on increasing. Now, the second thing is like this, it is inexpensive. That what I'm telling, it's somewhat cheaper in a sense, and you can connect that. Almost all it will comes, according to me, it will come around 32 port switch hub if you are going to take, means a maximum around some 20 to 22,000 in a market. So maximum. So that is a one important thing with an Ethernet. That's why it's very cheap. Coming to the next, wireless links. Today, this wired thing what we have discussed still now, and wireless LANs is also there, which we have seen one access point will be there. To that access point within a several meters, For example, maximum 500 meters, from 100 to 500 meters, you can connect, and you can connect your devices like our laptops and all. Today, almost all we are in our department also, we have seen how your laptops and mobiles you are connecting to the access points of a BMSIT. That is wireless LAN or wireless networks. Wireless links transmit electromagnetic signals, that is microwaves or a radio waves or infrared waves. Usually we are going with a radio waves and microwaves. Now wireless links all share the same wire, so to speak. The channel is to share it efficiently without unduly interfering with each other. Most of this sharing is accomplished by dividing the wire along the dimensions of frequency and space. This is the thing. What do you mean by this? I will tell you very clearly. Assume that one access point is there, right? We'll fix to there, and I will tell 100 meters you can walk. Not only for single device, keep in your mind, not only for single uh, laptop or not only for single mobile. In our department around we are 200, more than that members are there. Assume 250 members are there. In and around in a 250 members, sorry, we are connecting around 150 to 180 members, assume. So all 180 members connected to single access point at a time. Then how a different frames will move in that particular access point. From our adapter, it's going out, and it should go to that particular access point. From there, the frame should go. Again, that access point, whatever is there, is a wired connection. Thereafter, it has to go to the server. Now, how in a hair channel, how these frames will go and how it will take into the consideration. So what frequency your access point, whatever is there, it's taking into the consideration. So it depends on different frequencies. How? For example, I'll tell you like this. The signal of that access point will works in one particular frequency. Assume the frequency will be chopped, means that frequency will be inner, chopped, and different small frequencies will be given to the different members. That is, for example, 5 megahertz it's working. Assume 5 megahertz it's working. So 1 megahertz or 0.5 megahertz will be given to one person. Again 0.5 megahertz will be given. Like that. 5 megahertz means 0.5 megahertz, 10 members can be taken into the consideration. Like that. So what the second sentence is telling there, you can observe, most of this sharing is accomplished by dividing the wire. Here not a wire. That's along the dimensions of frequency and space. So whatever a space, you must be within that particular space, that is 100 meters or 200 meters of your access point capacity, you must be there fast. And that frequency, whatever you are going to take, you are sharing that particular frequency with all others. Are you getting? So the speed of your internet will depends that how many members are being connected to that access point. If only 2 members have good internet, good speed. So numbers are keep on increasing. The limitation will be there for an capacity. Assume that today in a previous days and all in our BMSIT, the access points used to work with megabytes, means megabytes capacity. Now gigabytes capacity is there. So the switches, whatever it will work, it will have some capacity or a bandwidth. Within that, it should work. So how many members are there? It will share that bandwidth to everyone. So exclusive use of a particular frequency in a particular geographic area may be allocated to an individual entity such as a corporation. Now how these things, so now for example, how these things will work, like Airtile, you can take or any corporation companies, you can take other companies will be there. The particular frequency range will be allocated to them. Within that particular frequency, they have to use in a geographic area of that particular area, like Airtel, Bharati Telecom, and Reliance Jio is there, and Idea Birla is there. Like that, they will purchase. That's a bidding. That's a bidding spectrum, bidding 2G spectrum, 3G spectrum. Now today 4 and 5, we are going with 4.5 GB. Sorry, 4.5G spectrum and 4.5, not 5G still. We are having 5G spectrum is not there. So 4.5 we are almost all, and 4G spectrum we are using now. Some companies 4.5 we are stepping into now. So in this way, the wireless links will be shared based on frequencies, and some companies will be reserved with that particular frequencies. Coming to the summary of this particular chapter, what we have did, or a module 2. We introduced the many and varied type of links. First, we have gone with the links, and we have seen a different links there that are used to connect users to existing networks and to construct a large networks from scratch. So we have used that how links will be used. Then we looked at the 5 key issues that must be addressed so that 2 or more nodes connected by some medium can exchange the messages with each other. Means the end-to-end systems, host-to-host systems, which has been connected, how the information or a message can be exchanged from this system to the next system. In that, the main things are encoding. Means whatever a message is there, how a message is encoded into a wave format. That we had discussed, that is NRZ, NRZI, and the Manchester format, and then 4B by 5B. Coming to the next, the framing. The sequence of zeros and ones will be comes from physical layer, and that will be accumulated together as a frame. So how a frame will be identified means how starting and ending point of a frame will be done, how framing will be done. We have discussed in a last class, that means in previous classes, that is the using the byte stuffing and bit stuffing and the header size of that particular frame as the 3 techniques which is there. We had discussed that also. Now another important thing, after framing, frames will come, either that frames will have a errors or not. So errors should be detected. It means due to the noise and due to the transmission errors, maybe 0 will become 1 or 1s will become a zeros. That error detection should be done. So for that, different algorithms we have seen, that is a even parity, bit 2-dimensional bit checking. I have explained you the algorithm, and CRC, cyclic redundancy check. Also, we have seen the 2 methods. In that 2 methods, how a detection, only detection of errors will be done. If correction also, we have seen according to the lab program that 1-bit correction you can do using an humming code. That how it can be done, we have seen that also. Now after detecting the particular frame with an error, so receiver will discard that. Some information should be sent to the sender, where reliability of transmission should be there. So reliability transmission will be done by acknowledgements and the timeouts. It means sender will expect acknowledgement from a receiver. Based on the acknowledgement or based on a timeout, it will decide for the retransmission of that particular frame. That also we had discussed. Coming to the, in that we had discussed the sliding window protocols, that is stop and wait or a single bit stop and wait protocol. Then we have gone with the sliding window protocol. That also we had discussed in a class, that more than 1 or 2 frames can be sent. In that we have seen how the acknowledgements, what is the different disadvantages is there, to improve how the negative acknowledgement will work, or how the additional acknowledgement, sending the previous acknowledgement only back, so how it will work. And then we have seen how a selective acknowledgements will be sent. That means only the frames which has been received for that acknowledgement will be sent. The frame which has not received or discarded, the receiver will not send the acknowledgement. So seeing the acknowledgements, if acknowledgement not received, then automatically retransmission of that frame, that selective frame, will be done by the sender, which I told you that one of the best sliding window protocol, that is selective sliding window protocol that we have seen. Then we came to Ethernet things, that is a MAC layer. Then in there we have discussed that how a MAC layer protocol will work, how a control of access is done, and how CSMA CD will work, and how Ethernet frame will be there. Um, we have taken that frame and different parts of that frame we had discussed, and the transmitter algorithm of Ethernet we had discussed, that is one persistent algorithm we had discussed. Then how the busy link and delay links, if the collision occurs, what will be the waiting time, exponential back off, which we had discussed today, that things and all we had discussed. And lastly we had discussed the wireless links, which works on a frequency sharing, how it will be worked. So almost all data link layer, physical layer, which we had discussed in this particular unit. In the next unit, we'll step into the network layer, and which is a very important thing, where routing algorithms, bridges, switches, that when I shown you the video of that, we have seen how different things will play, and heart of entire your network, internet, we are going to see in the next module. Thank you very much. Any doubts, you can ask me. Any doubts? Any doubts? Any doubts?
Yes,
Doubts?
sir.
Okay?
Okay.
Okay, thank you.
Yes, sir.
Thank
Thank
you
you,
very
sir.
much. Thank you. Bye.